So right now we can represent this set in two forms. One is the roster form. So in this roster form, every element should be there in the curly brackets. So in this curly brackets, after every element, let's take you have 1, 5, 6. So after every element, you need to have these commas. If you don't have the commas, then it is not the roster form. And then there is a note that in the roster form, one element should not be repeated. So if you take one more, 1, 5, and then 1. So in this 1 is being repeated again. This is not the roster form. This is the roster form. So the next form is the set builder form. So coming to set builder form, in the set builder form, like now we have the set 1, 2, 3. Now this is in the roster form. So to represent this in the set builder form, we need to convert this into the text. So for example, let's take one more set A, E, I, O, U. I think most of you know what is this. These are the vowels. The elements in this are the vowels. So right now, to represent this in the set builder form, we'll take X slash. This slash stands for such that. So X such that the element whatever it is, let's take it's an element X. X is to all vowels. So right now we can understand that these are the all vowels whatever are there. So we can take all the prime numbers. 1, so not prime numbers, let's take the natural numbers. 1, 2, 3, 4 and dot to infinity. So in this is to represent this in the set builder form, we will write X such that X is to all natural numbers. Now we got what is a set builder form. So next we will discuss about the types of set. So coming to the types of set, first one is the null set. So by the null we can understand that in this null set there are no elements. So if you take this, there are no elements in that. So a set which has no elements in it is called a null set. And the next one is the equal set. So in the equal set, let's take an example. So equal set is nothing but the set of A should be equal to set of B. That means that every element in set A should be there in the set B. So let me take A is equal to 1, 4, 8. So let's take a random number. And then B should be also equal to 1, 4, 8. Then the A set will be equal to B set to P. This is the equal set. And the next is the equivalence set. So in this equivalence set, it is like right now you have this. Wait a second, let me just write it some big. Equivalence set. In this equivalence set, we'll not bother about what are there in this. Like now we have 1, 4, 8 and 1, 4, 8. So but in this equivalence set, the A set, for example, let's have the A set has 2 elements in it. Then even the B set should have 2 elements. Then that set will be equal to equivalence set. So for example, let me give you an example. 1, 8, 1. So this is A set. And then B can be anything. 3, 2, 1. And then should not exceed this. There should be only 3. there are 3 in the A set, then there should be 3 in the B set. This is called the equivalence set. The types of set, there are cardinal number of set or order of set. So right now this is nothing but the number of elements in a set. So for example, let's take a set A which has 1, 2, 3. Then the number of elements in this, there are 3, right? Then the n of A, which is nothing but the number of elements in A, is 3. This is the order of set. And then next we will discuss about the operations on sets. So different operations. So first we'll discuss about union set. So coming to the union set, it's nothing but in the union set we'll just take the common in the both sets. So let me give you one more example. So let's take set A. So A will be equal to something like 1, 2, 4, 5. And then B will be equal to, okay, let's take 4, 5, 10, 12. So right now we have this both elements, we have this both sets which have some elements. Now to get the union of these both sets, we will represent as A union B. We will represent it in this form. So to get the union, let me write over here. So to get the union of this both A union to B, we need to see what are the elements which are not matching in this both sets. Now 1, 2, it's there over here, but it's not there over here, right? So we can just take 1, 2. And then we have 4 which is there over here. So these are both matching. So we'll not take this. We'll just take that as common. And then only write it once, 4, 5. And then next we have this 4, 5. As we took it common, we need to not write it again. So let me just write it side. So A union to B will be equal to 1, 2, 4, 5, 10, 12. So as the 10, 12 is not repeating again, we just wrote that once. As it is repeating twice, we just took it common and then wrote it once. So this is union set. So the intersection set, it's nothing but just the elements which are repeating in both the sets. The elements which are equal in A set to B set. So let's take, we have set A which has 1, 2, 3, and we have set B which has let's take 3, 2, 5. Okay, you can even take it more. So 5, 8. So in this both we will just denote it as A intersection to B. So we'll denote it like this, and then the final value we'll get is the common elements in both. 2 is the common element. So 2 and 3. So this is the output of this both. So this is the intersection of these two sets. So the next one is the difference. I think most of you know a difference like subtraction of the sets. Yes, subtraction. Now in the subtraction, we need to just subtract this set from this set, but it's somewhat different. So A minus B will represent it like this. So let's take a set A which has some elements 1, 2, 5, 6, and then we'll take set B which has some more elements like have here 1, right? So we'll take 1, 2, 8, 9. So in this what we'll get is that we'll subtract this both. First we'll subtract A from B, A minus B. So in that we'll subtract 1, 1. So 1 minus 1 it's 0. So we'll absolutely get this and then this. Right? So we'll get it directly 0. So we'll next take the next two numbers which are actually not there in this set. So we'll get 5, 6. But we'll not subtract this from this. We'll only subtract the same elements which are repeating. We will subtract the intersection elements. So the other element will be the direct number for this. So in b minus a, we'll take the b as the first and then we'll subtract it. So that we'll get 8, 9. So the intersection will be 8, 9. 8, 9. This is the difference between two sets. So that's it for now. And next we'll even learn about the relations in the set and the functions in the set.